Yeah, thank you. Thank you very much, Mr. Dominic, for the introduction. So, good morning to all the participants. As usual, we have more than 150 participants now. Normally, all of you know our webinars are quite popular, and we always have 200 plus participants. So this time we are coming back after 2 months. Last 2 months, almost 2 months, we didn't had any much show because we were busy in making programs, direct programs. In between, we had a program for Bangalore last month, where there are about 150 people participated. It was conducted in a hotel. Then in between a few large corporate organizations, we were doing some training programs, then some programs for electrical inspectorate in Bombay as well as in Nagpur. And in the coming week, for example, the programs for railways is going on, and so many webinars, not webinars nowadays, direct trainings are going on. So we are back with our 24th webinar along with BNG, but as a part of Vidyut Surakshit Bharat Abhiyan. I'm sure most of you know about Vidyut Surakshit Bharat Abhiyan. This is the 126th program, starting from 30th June 2021. We conducted a lot of programs and we covered so many subjects. And today, we are going to talk about a subject, understanding and preventing of electrical fire and short circuit, of course, the basic safety, fundamental improvement required in electrical distribution in buildings. So, and this time we are going to talk about electrical and electronic equipment safety. Equipment safety in the sense, most of the time, fire happens on the equipment. For example, air conditioner. If we look at the statistics all over India, the air conditioner fire alone is creating a lot of injuries, and a lot of people are dying. Several cases we can discuss in this particular thing. So specifically, we are covering a subject which is very much related to electrical and electronic equipment safety. Please note that we will not be able to discuss all the subjects in 2 hours, because if we try to discuss so many subjects in 2 hours, finally it becomes a mess. So we have decided to go with small subjects in one webinar, and so that more information, accurate information can be passed on. So today we are going to discuss about clause 4.5 of IS 732, which is basically protection of electrical and electronic equipment from voltage disturbances. There are 2 subjects, voltage disturbances and electromagnetic interference. So we are going to discuss only voltage disturbance. So basically, this is the clause 44.2 of IEC 60364 444. Protection for safety, protection against voltage disturbances, basically to ensure, these are the measures to ensure that your equipment are working safely and efficiently without a failure. As I said, most often equipment failure are creating hazards. In parallel, we also should look at the standard IEC 60661, insulation coordination of equipment within low voltage supply system, part 1, principles, requirement and test. Basically, I am referring to a standard which is a little bit new. 60661 is not a new standard, but I am referring to the 2020 standard, which has added a lot of special requirements and testing measures for electrical equipment or electronic equipment, which need to be made mandatory in India in order to have a safe installation. Say, for example, once when you, especially for critical application like hospitals, like large industrial facilities or sensitive areas, when you select your electrical appliance, you have to be analyze whether the equipment is satisfying the requirements of this particular standard, because this ensures that your equipment is able to perform under various disturbances. So today's subject, the protection of low voltage installation against temporary overvoltage. Temporary overvoltage means you know very well that our voltage is 230 bar 400 volt. Normally, sometimes we also say 240 line to neutral and 415 phase to phase or line to line. In the presentation, the voltages which I am referring to is applicable to 230 volt line to neutral and 400 volt line to line. Over voltages are any voltage which is higher than these levels. For example, more than 230 or more than 400. Of course, up to 10% or in some countries up to 15% plus is allowed as a normal case. Say, for example, in India, 230 plus 10% means up to 253 volt between line to neutral or line to earth is a nominal voltage, or the maximum voltage can be up to 253. Line to line, it can go up to 440 volt, for example. Any voltage which is more than these limits, more than 253 or more than 440 volt line to line, or 253 between line to neutral or line to earth, is termed as a temporary overvoltage. Temporary overvoltage, if it persists for a longer time, your equipment will fail. It may create its insulation will deteriorate. It may take more current, and if the protective mechanisms are not working properly, this may lead to a fire accident. Now, here we are going to talk about the three fundamental safety measures which is required. A fault between a high voltage system and the earth in transformer substation that supplies the low voltage installation. That means the fault on the HT side of the transformer, which is going to influence the LT installation. Second one, loss of supply neutral in the low voltage system. In the sense, in case of the neutral disconnection, what is going to happen? A short circuit between line conductor and neutral. So in the LT system, low voltage system, if there is a short circuit between line and neutral, of course, the other two phases are going to have a stress of voltage, and if the disconnection time is more than the specified voltage, your equipment may fail, which may lead to fire accidents. This means a short circuit between line, conductor, and neutral. This means there is a problem in one of the circuit, and that particular circuit tripped. But parallelly, an accident can happen in the parallel circuit, because the parallel circuit is stressed with more voltage for a longer duration. If the disconnection time is more, then we are actually in trouble. Most of our electrical installation, you know very well that, okay, before electrical installation, all of you know that once when we use our wash basin at our house, we open the tap, wash the hand, the water goes to some kind of pit, or somewhere it goes to the earth. If you use more water, often your, in villages, the water goes to the pit, and if you use more water, pit is more or filled with water, so we make a bigger pit so that water goes to, more to earth. Most often, this mechanical phenomena has been applied in electrical engineering. People think that all unwanted electricity, it should go to earth. As a result, you know very well, most often our electrical safety requirements are connected to bigger earth pit, multiple earth pit, chemical earth pit, and so on. Actually, we are not going to talk anything about this mechanical mind, because a lot of electrical installations nowadays are designed with the mechanical ideas. Mechanical ideas, if you design electrical installation, of course, it won't work properly. It may create larger issues. One of the example is, you know very well that in all my presentation, I always try to explain the transformer having a separate earth pit, the transformer neutral having separate earth pit, two numbers of earth pit, the main distribution have two more earth pit, then UPS, elevator, and the equipment have separate. Every part of the electrical installation is connected to separate earth pit, and engineers try to do a bigger earth pit, chemical earth pit, and so on. The basic idea is people think that all unwanted current, which is going to create a hazard in the installation, it goes to earth. If I have a bigger earth pit, what I mean is an earth pit with a very low resistance. Actually, we are not going to talk about this particular phenomena. If your electrical installation is following this kind of method or this kind of a phenomena, the further slides are not related, or you cannot apply the principles written in the standard for this kind of an electrical installation where so many earth pits with very low resistance of the earth electrode is immaterial is applied. Of course, sometimes we call this unstandard or non-standard installation as TT or TNS. It is neither TT nor TNS. It's a very well undefined network. So further slides are not applicable to an undefined network. In an undefined network, we don't need to talk about safety because there is no safety. You can be at trouble anytime. Your equipment can burn anytime. So most of the installations are running without problem because you are lucky. Just because of luck, just because of God, probably the installations are working properly. So this kind of undefined network, please don't try to apply whatever I'm going to explain in the future slides. Undefined networks are unsafe. It can only create trouble to you. Probably there is no trouble for the last 10 years because you are lucky. So to start with, you know very well that high voltage damages electrical appliance. This was a news recently from Lucknow. It says something happened on the high voltage side of the transformer and a lot of electrical appliance at consumer premise burned down. Another case in Chandigarh, voltage fluctuation damaged appliance worth lakhs. So these are actually the problems which can be expected in any electrical installation once when there is a fault on the high voltage installation. If you have an undefined network, of course, it's a big problem. If you have no properly designed electrical installation, then these such problems are expected. I'm just showing a picture. High voltage side of a transformer, body of the transformer which is connected to an earth electrode high voltage side RE. You have the secondary side of the transformer, neutral of the transformer is connected to a separate earth electrode. You have the electrical installation. There are two dotted lines you can see here. This denotes a TNS system and the second one denotes for a TT system. Whenever there is a fault on the HT side of the transformer, one of the classic example is whenever there is a surge arrestor failure on the distribution or in an industrial premise, whenever there is a surge arrestor failure on the high voltage side of the transformer, lot of equipment at the low voltage side of the equipment start burning. The reason is once when there is a fault current through the earth electrode, it creates a high voltage or a voltage gradient is created at this particular location. This voltage gradient can be transferred to an equipment and your equipment may fail. It is going to create three issues. First is an over voltage a stress on your transformer low voltage winding, a stress on your equipment, a stress or a shock voltage between the equipment and the local earth. These are the problems which are expected. U1, U2, U3. In the presentation, probably you will be seeing U1, U2, UF, but just to be sure that U1 means the stress at the transformer low voltage winding, U2 is the stress at the equipment, UF is the shock voltage. Now, IS 732 has specified under any circumstance, the shock voltage in an installation shall not exceed this particular graph. Your installation can be a low voltage, a medium voltage, a high voltage, extra high voltage, or whatever it is. The maximum allowed shock voltage is as per this particular graph. I just put it in the table. Within 100 milliseconds, the touch voltage shall be reduced to less than 650 volt. Within 500 milliseconds, less than 200 volt. Within about 1000 milliseconds, less than 110 volt. Within 10 seconds, about 65 volt. So this particular graph is used universally. IS732, you can look at this particular picture. What it says is, against shock, the first safety measure is the shock voltage within the installation where people are living, where people are working, must be reduced to lesser than this particular limit. You can see on the x-axis the time of the duration of the fault, and on the y-axis you can see the fault voltage. Fault voltage, say for example, 800 volt, 10 milliseconds. About 100 milliseconds, it's about a little bit lesser than 700 volt. Now you see this particular graph, the blue color line. I don't know whether it's clear to you or not. Probably it's clear. The IS732, which is the code of practice of electrical wiring, as well as the upcoming National Electrical Code, has included this particular graph. Please note that this graph is from the IEC standard basic safety measure shock protection standards. So we are not going to include any new thing. It is adopted internationally. Every electrical installation must ensure that the shock voltage is made lesser than this. Similarly, the second point is power frequency stress voltage. Stress voltage in the sense, due to some reason at the high voltage side or at the low voltage side, a temporary over voltage is happening in your electrical installation. Number one, your electrical appliance, including the wiring, including the installation equipment, must be able to withstand certain minimum limit. And that particular limit is included or shown in this particular picture. U1 and U2 means the stress voltage on the transformer or in your installation. More than 5 seconds, U0 plus 250 volt. I have a better table. I will show it later. Up to 5 seconds, U0 plus 1200 volt. What does it mean is up to 1200 volt for 5 seconds can be experienced between a phase conductor and the earth in an electrical installation. This stress is the accepted level. Your equipment and your wiring must be able to withstand this particular stress. So 2 points. One is the shock voltage, as I shown you in this particular picture. I'm sure you are able to see the limit of the power frequency fault voltage. It means the shock voltage limit. The number two, the stress on the equipment also has to be limited to almost this much level. It also means your equipment is able to withstand, say, for example, up to 5 seconds, 1200 volt. When you buy an equipment, when you know that your equipment can withstand only 1200 volt plus 230 volt for up to 5 seconds, you must ensure that the voltage which is going into your electrical appliance due to various reasons are limited to a level lesser than this. Otherwise, your equipment may fail. So there are two things, higher than 5 seconds and less than or equal to 5 seconds. This depends on the high voltage supply, whether the high voltage supply is earthed, solidly earthed, or impedance earthed system. Not very important now because I have a better slide which I will show you. Say, for example, you have an electrical installation, something like this. You have a transformer from the public utility company. The public utility company, the body of the transformer, including the surge arrestor, is connected to an earth electrode. Then there is a neutral earth electrode. Both are interconnected or both are close by. Let's say, for example, both are near maybe 1 meter, 2 meter away. So electrically connected earthing of the high voltage system and the neutral of the low voltage system. Whenever there is a fault on the transformer high voltage system, once when the fault current goes through this particular earth electrode on the ground, a voltage gradient is created. Now, the important point you should think is the complete low voltage electrical supply is referenced to the neutral, and the neutral is connected to the point with which the energy or the fault current is dissipated, the high voltage fault is dissipated, which is having a potential gradient. So what happens is the phase and the neutral is referenced to a point A. Let's say, for example, the fault current is 5 kiloamperes, and the earth electrode resistance is, let us say, 5 ohm. So 5 kiloampere into 5 ohm, approximately 25 kV will be the peak of the voltage gradient. Now the line and neutral are stressed or referenced to this 25 kV. That means the line and neutral are at 25 kV, whereas the body of your electrical installation is connected to electrically separated place. As a result, this one is at zero potential. Basically, between the body of your equipment and the phase and neutral conductor, you have a voltage stress. And if your equipment is unable to withstand this particular stress, of course, your equipment is going to fail. We are going to look at these voltage limits and some of the techniques which can be applied or which is recommended in the standard to get rid of this particular problem. The other issues are, the first issue is a high voltage fault. The second issue is the loss of neutral. In case of a loss of neutral is nothing but from between your house and your transformer, the transformer supplying energy to your electrical installation. If there is a neutral disconnection, the other two, some of the phases may experience a voltage between phase and neutral. You may experience a voltage up to 1.73 into U0. So approximately about 440 volt or 400 volt can be experienced. The phase-to-phase voltage will be applicable under this condition in your single phase electrical equipment, depending upon what equipment you switched on, depending upon what kind of equipment are connected to the other phases. Basically, two phases will experience this much voltage to the respective neutral. And if this voltage is not disconnected before certain time, of course, your equipment is supposed to fail. The third issue is sorry. The third issue is stress voltage in the event of a short circuit between line and neutral. In the low voltage wiring, once when there is a fault between line and neutral, the voltage between the other line conductors and the neutral conductor can reach up to 1.45 times U0, means 230, 1.45 times of U0 for up to 5 seconds. So basically, I put these stress voltages in this particular table. TOV is creating failure in equipment in TTTN system. Type of fault is the high voltage fault, for example, 1200 volt plus 230 volt up to 5 seconds. This is applicable between line to P, means the protective earth, applicable for a class 1 equipment, of course, because class 2 and class 3 equipment doesn't have a protective earth or doesn't need a protective earth. So L to P, class 1 equipment, your equipment must be able to withstand that particular voltage. 250 volt plus 230 volt for a time greater than 5 seconds, line to P, applicable for a class 1 equipment, your equipment is supposed to withstand that particular voltage. So basically, your equipment is supposed to withstand the two conditions mentioned here, both the voltages 1200 or 250 plus 230 volt. Of course, the electrical designer or the energy supply company shall ensure that the voltage is limited to a level lesser than this. Don't cross 1200 volt. It should be lesser than 1200 volt. Then only the system will work. They have to make that particular arrangement. In case of an industrial installation, the electrical designer shall ensure that the voltage applied to your equipment is limited to a level lesser than this particular stress voltage. This is number one. Number two, when you select your electrical equipment, you ensure that your equipment is able to withstand these voltages. So on one side, your design ensures that the voltage is limited to less than 1200 volt. On the other side, your equipment is able to withstand 1200 volt up to 5 seconds. So by this method, you are able to achieve safety. Please note that this is applicable to between line to PE, line to earth. Loss of neutral is between line to neutral up to 440 volt can happen for an unlimited time. Of course, this time, unlimited time, it depends. It is number one applicable for a public electricity distribution system. You have to report the problem to the electricity board. Somebody may come after an hour or probably after 2 days to rectify the mistake. That is why I put unlimited time. Generally, in developed nations, this kind of the voltage, the time restrictions are given in the standard. Say, for example, 10 minutes or 30 minutes, not more than that. But if you have this kind of a system, in order to safeguard your equipment, please note that this is applicable for both class 1 and class 2 equipment. The only chance is to disconnect the supply. There are voltage relays available. You can put a voltage neutral disconnection relay is available. You can put a neutral disconnection relay and you can trip your shunt trip, or you can put a contactor and trip the supply. So this is the safest method. But technically speaking, in an industrial installation, this kind of a situation is very, very rare. Of course, for public distribution, this is especially public distribution overhead line, this condition is quite normal. Also in public distribution, if the joints are not proper, then such problems are expected. The third issue, short circuit between line to neutral. Please note that this is applicable between line to neutral. The first two are between line to earth. The third one is between line to neutral up to 335 volt for 5 seconds. You can expect a temporary over voltage between line to neutral, both for class 1 and class 2 equipment. And here your equipment must be able to withstand the stress voltage. So if we leave the second case, the loss of neutral, in an industrial environment or in a critical environment like a hospital or a data center or BMS or instrumentation system, you should ensure that equipment operating with 230 volt or 400 volt is able to withstand 335 volt between line to neutral for 5 seconds. It must be able to withstand, no compromise on that. Similarly, the second one, for example, 1200 volt plus 230 volt between line to earth, applicable for a class 1 equipment, your equipment must be able to withstand. You also should ensure that your design should be made in such a way that the voltages are limited within this tolerable voltage and duration what I have mentioned. If the voltage and duration, if the design is not taking care of it, of course more voltage comes and your equipment will be in trouble. This 5 seconds comes from the disconnection time. Disconnection time is established in the standard. You can see here, TN system. First of all, there is an electrical network. There is a transformer. As I told, I am talking with 230, 400 volt system. Kilowatt hour means the point of commencement of supply. Up to kilowatt hour, it is the scope of the electricity supply company. If you have a public distribution system, of course, if you have your own transformer, then from the high voltage side onwards, it is under your scope, applicable for industrial and commercial premises. In the fixed part of the electrical main distribution circuits, the disconnection time maximum allowed is in case of TN system 5 seconds, TT system 1 second. The load circuits, the final circuits, 63 amp socket outlet devices or 32 amps fixed equipment, the disconnection time specified or made recommended in the standard. These are the maximum recommended time. Please understand. In TN system, 0.4 second. In TT system, 0.2 second. Actually, the 5 seconds of, say, for example, in a line to neutral short circuit, 335 volt, which is shown in the previous slide. Say here, line to neutral short circuit, 335 volt, 5 seconds. Line to neutral, applicable for class 1 and class 2 equipment. It comes from the disconnection time of TN system, 5 seconds. But please ensure, or please be sure that these time in the main distribution circuit up to 5 seconds is recommended for the safety measure called as protective equipotential bonding and automatic disconnection of supply. Here, protective equipotential bonding means the metallic parts in your building are interconnected in such a way that there is no fault voltage, or the fault voltage is limited to a level lesser than this particular limit. And if you are not making protective equipotential bonding, then of course this 5 second and 1 second is not applicable. You have to go for the time which is of course specified in IS 3043. 220 volt fault, you are supposed to disconnect within 0.17 second. So this time which I am showing is from IS 732, but please note that these disconnection times are applicable for the safety measure called as protective fault protection is achieved by protective equipotential bonding and automatic disconnection of supply. If protective equipotential bonding is not carried out, then the disconnection times are quite faster. Similarly, in the electrical installation, voltage impulse withstanding capacities or insulation coordination is also an important subject. Insulation coordination in the sense we are using different kind of electrical equipment and components in our network, starting with the meter, then we have a main switch, then we have sub switches, we have the bus bars, we have the meters, we have the wires, we have the switches, sockets, and the fixed installation, and we also connect some of the socket outlet devices, we connect some appliances. So here, this part of the electrical installation is categorized into 3: mains incoming, fixed installation number 2, connected device number 3. Category 4, category 2, category 4, category 3, and category 2. This means the electrical appliance used at the origin of installation or point of commencement of supply must be of category 4. Example, a 230 volt equipment, 230 volt between line to neutral equipment must be able to withstand 6 kV, 6000 volt voltage impulse withstand. Means a surge voltage of up to 6 kV, these equipment are able or supposed to withstand. At the fixed part of the electrical installation, starts, say for example, your main distribution board, your cables, your sub distribution board, your switch, socket, your light fittings, your fan. These are fixed electrical installation. So all the fixed electrical installation up to the socket, we are supposed to, for the purpose of equipment safety, we are talking about equipment safety. For the purpose of equipment safety, the equipment used in the fixed installation must be of category 3. Means a 230 volt equipment must be able to withstand up to 4 kV voltage impulse. Voltage impulse is nothing but surge voltage. It is a classified example of testing. Once when we go further into the next 2-3 slides, you will be able to understand what I am talking. Fixed part of the installation, for example, your fan, light fittings, and so on, a class 1 equipment. up to 4 kV, it is able to withstand. If I ask the question, are we checking this parameter while buying our electrical appliance for our house? Of course, most of the time we don't. Then the connected equipment to a socket must be of category 2, 230, example 230 volt application must be 2500 volt. What does this mean is, in the electrical installation, we are going to have some big equipment, we are going to have some medium size equipment, we are going to have a little bit smaller equipment with respect to its insulation. We are going to also have sensitive electronic equipment. The sensitive electronic equipment comes under category 1. For example, a surge voltage of 1500 volt. Now, the most important point which we should understand is IS 732 means the IEC 60364 used as a wiring regulation globally in Europe, in Britain, in America, all over the world. The wiring regulation says in your electrical installation, you must see that the equipment are able to withstand a certain voltage, and in the fixed part of the installation category 3, connected equipment category 2, and category 1 equipment, you are not supposed to connect directly to a public LV supply. Not suitable for direct connection to a public LV supply. Public LV supply in the sense, the power supply you are getting from the utility company, a low voltage power supply you are getting from the utility company. Whereas in an industrial installation, if you have the power supply as a high voltage supply, let's say for example 11 kV or 22 kV system, and if you have your own transformer, then the situation is a little bit different. Your system design should ensure that the voltages, these stresses are minimized to a very, very low level. Now, this categorization is very important. If we are not able to select and erect the equipment according to this, of course, unnecessary voltage stress goes into your equipment. Your equipment's insulation will fail or degrade. Insulation degradation will lead to failure of the equipment. And if you look at from the previous slide, the disconnection time, if the disconnection time is not met, of course, your installation will be in fire. So basically, the voltage stresses are creating insulation degradation. After some time, your equipment is failing, and at that particular time, the supply must be disconnected by the protective device. And if the supply disconnection is not happening, of course, then an accident happens. How can you see this parameter in the manufacturer's catalog? You can see I'm showing an MCCB catalog, over voltage category, according to IEC 610101, category 4. This is a multimeter. You can see here MECO multimeter on somewhere safety. It is, you please note that it is written on the safety part, safety, double insulation, and category 3000 volt DC, category 4 600 volt AC and DC. Say for example, here category 3000 volt AC DC, category 4 600 volt AC DC. What does this mean is, you can use this meter if the operating voltage is up to 1000 volt in a category, that means not at the main distribution board, not at the point of commencement of supply. After the point of commencement of supply, you can use this meter up to 1000 volt AC and DC. At the point of commencement of supply, you can use it up to 600 volt AC and DC. Of course, where this 600 volt AC DC is applicable, maybe is the question which comes to your mind. Yes, 690 volt is used in several industrial applications. Say, for example, all the wind turbines, the large wind turbines which is working in India, more than 200, 300 kilowatt onwards. Nowadays, the wind turbines are even 2-3 megawatt. So all these wind turbines, the connected line is at 690 volt face to face. So if we take this particular multimeter, it says for that particular application, you cannot use this multimeter. That is how it is. Similarly, this is an MCB, over voltage category 3. Another MCB from the same manufacturer, over voltage category 4. Very simple to understand. The first MCB, over voltage category 3, you cannot use at the point of commencement of supply. If you wanted to use the MCB at the point of commencement of supply, you have to use this particular model, which is, of course, even a bigger one. These 4 categories are specified in IS 732. There are 4 categories, category 1, 2, 3, 4. 4 is 6 kV, 3 is 4 kV, 2 is 2.5 kV, and 1 is 1500 volt. But please understand that category 1 devices are not for direct connection to a low voltage power supply. Now, if you look at a control panel, say for example in an industrial environment, you have, imagine you have a class 1 control panel. Class 1 control panel, this one, the red color one, is the main power circuit, 230-400 volt power circuit. That means the power is coming, it is doing something, probably a sub-distribution, and it goes out to the load, probably to some drives or whatever. Then you also can have an auxiliary contact. You can also have SELV or PELV, extra low voltage supply, into the control panel. Now, if you have a control panel in this fashion, what we should ensure is between the main circuit and the auxiliary circuit SELV, PELV, number one, there must be a physical insulation, physical separation. Between the auxiliary and this particular SELV and PELV must be installed within the double insulated part of the installation. Means that mechanically, the SELV and PELV circuit must be insulated. This also means in case of a problem on the main circuit, a person who is working on the SELV, PELV or on the auxiliary circuit are not getting electrocuted. While installing this particular panel or while designing the electrical panel, you must understand, the panel manufacturer must understand and look into the standards about the location where the panel is going to be installed, about the impulse withstand of that particular location, basic insulation between different parts, the requirement of basic insulation, double insulation to SELV and PELV. You must understand these requirements and make the panel in such a way that it is satisfying the overall requirement. Say, for example, for basic insulation coordination standards are there, 60664 part 1. I am just showing some of the part. This is applicable for an equipment. Let me read it. Basic insulation and supplementary insulation of solid insulation shall be designed to withstand the following temporary withstand over voltages. Short-term temporary over voltage U0 plus 1200 volt with duration up to 5 seconds. Long-term temporary over voltage U0 plus 250 volt with duration longer than 5 seconds. As I said, this is between line and earth. The panel board has to be made in such a way that it is able to withstand, the control panel is made in such a way that this is withstanding these voltages. Now you have something working with SELV, let's say 48 volt DC. You have to have basic or supplementary insulation. The performance validated can be declared by the manufacturer as a rated temporary withstand over voltage value. The manufacturer, while designing the panel board, he has to consider these points and he has to declare the performance of these values. Reinforced insulation shall withstand twice the temporary withstand voltage specified for basic insulation except when partial discharge test is used. So basically what I'm trying to explain to you is every apparatus, every equipment which we are using in our electrical installation, it is supposed to have certain voltage withstanding levels. Example of a control panel I am showing. You have a control panel with a mains power supply with SCLV, PLV, and auxiliary contact. Now the standard recommends that the insulation levels between these items, these various, class 1 part of the equipment and SCLV, PLV, for example, the basic and the supplementary insulation of the solid insulating material which you are using must be able to withstand this much voltage, and the manufacturer should declare the value. This is the fact which is included in the standard. Now, if I ask the question back to the industry, what I have found is most of the industry, especially say for example control panels or instrumentation, BMS, most of the places, this information is quite new for the engineer. They really often sometimes don't know. I'm only putting an example of a control panel. This example can be put for several applications, several load, several equipment we can put. Basically, the equipment manufacturer are supposed to make this as a part of the installation. Recently, I came across a particular installation. It was a control panel imported from Germany for the OEM. And now the OEM thought that the cost of import or cost of manufacturing in Germany or in Europe is, let us say, for example, 2 lakh rupees. And the engineer in India counted the number of components inside this particular panel, and he told that I can make this panel for 1.5 lakh. So about 25% lesser, at a 25% lesser cost, we are able to make this particular panel in India. That was the argument. But then the panel was made, and this particular test is completely ignored. And then this panel is exported back to another country, and very simple, they rejected the panel and it came back. So the applicable technical points you should take care of in this case is clearance, creepage distance, solid insulation, dielectric test are often disregarded in designing and testing in our electrical installation. And basically, if these points are taken care very well, your equipment is able to withstand the voltage, the stress voltage. There are 2 points. One is the stress which is applied to your equipment must be limited to certain level. Number 2, your equipment must be able to withstand a certain level. This level is here, which is written U0 plus 1200 volt between line to neutral up to 5 seconds, or in the previous slide, which I have shown you. Now, electrical separation. Electrical separation is a protective measure in which basic protection is achieved by basic insulation. Fault protection is achieved by simple separation of separated circuit. Very simple to understand. You have the incoming, you have an isolation transformer. With the isolation transformer, the secondary side of the circuit you are isolating. As a result of this electrical separation, lot of problems which is existing at the input side of the isolation transformer can be solved at the output side. But as I said earlier, if your equipment withstanding levels are unknown to you, then this simple separation also may not work. At the output side of the isolation transformer, for shock protection, IP system, unearthed systems are recommended. I'm sure most of you know that there are some news in the media, there are some videos in the YouTube which says an young entrepreneur or an young company has invented a shock-proof panel, and they demonstrate that after putting this particular special panel, even if you touch the live conductor, phase conductor, nothing happens to you. Or even if you touch some of the live part, there is no shock. It's not a magic. It is called as isolation, simple separation. You use a small isolation transformer, you separate the electrical appliance. Now, the purpose of this explaining this particular subject is the IS 732 make some recommendation. The recommendations are This protective measure, say for example, simple separation, first of all, at the output side, you can go for IT or TNS system. In case of TNS system, of course, the safety measures for TNS must be implemented. In case of IT system, this protective measure shall be limited to the supply of one item of current using equipment supplied from one unearthed source with simple separation. The electrical separation is first of all recommended for one current using equipment. One of the example is solar PV, the inverter of solar PV, or say for example an UPS, because the UPS rectifier part of the UPS is unable to withstand some voltage or unable to withstand because it has got sensitive electronics. You make a electrical separation. As a result, you ensure that your equipment are able to withstand it. When more than one item of current using equipment is supplied from an unearthed source, a simple separation, the requirement of Annexure C of IS 732 shall be met. For example, all equipment meet the basic protective measure, live parts are insulated completely, and it can be applied for voltage up to 500 volt. Separate wiring system is required. If you are not using separate wiring system, then you have to take care of some of the mechanical damages which may arrive, and special requirements are there. The exposed conductive part of the separated circuit shall not be connected either to the protective conductor or exposed conductive parts of the other circuits or to the earth. It means you are having an isolation transformer, which is technically called as electrically separated circuit. Output of the isolation transformer, you are going for a unearthed system called as IT system. You have enough number of electrical appliances connected to this separate electrical supply. Under that condition, the earthing shall not be connected to either the protective conductor, the exposed conductive part of these equipment, means the body of those equipment shall not be earthed. It shall be floating. These are the requirements. Now, some of the application which we can see is solar PV, especially the inverters which is used in solar PV, the UPS and so on. We can apply this technique to several electrical appliances. As I said, there are some claims which is coming. Somebody invented a panel, a black box, which is protecting against all the problems or against shock and all. It is nothing but electrical separation. Now, there are some products which is claiming some unnecessarily or unrequired, not at all required specifications. Say, for example, products creating trouble in an installation. One of the product which already created trouble in the market and which is going to create more trouble in future is digital grounding system or digital grounding. If you Google, you will be able to find out more information. Digital grounding system, the companies claim that this equipment is directly from the God. It saves all your electrical safety problem. It saves all your equipment problem. It is a static charge eliminator. It reduces neutral to earth voltage. It detects surges and convert it into heat energy. Equipotential bonding is done. Electrodes, earth electrodes are not required. And whatever the electrical trouble which you think in your mind, there is a solution with this particular device, is the claim of the manufacturer. What they do is there is a plastic box, 3 small wires goes into the plastic box, 2.5 square mm wire, there is a 63 amp MCB. I am showing you one of the case study which I made. There is a plastic box with 3 LED lights, a lot of MOVs are connected according to the manufacturer, and there is a bus bar, a large bus bar. You can see here, there is a large bus bar. All the outgoing equipment, nearby equipment, the protective earthings are connected to this common bus bar. Then the claim is this device is the device which is going to solve all your problems. Actually, what happens is internally, these companies are shorting the neutral and the earth. By making a short circuit between the neutral and the earth, the potential difference between neutral and the earth has been made zero. But this equipment will create a lot of problem. The neutral current, the partial neutral current will flow through all over your electrical installation. And this device is going to create a fire in other circuits, not in the connected circuit of this particular device. Probably the connected circuit of this device doesn't have any problem, but other circuits are going to have serious issues of failures and fire. If my request to people, those who are using it or those who are going to buy this particular device, please think twice before buying this. Let me use a word from not from the dictionary. It's a nonsense. Please don't use this electrical nonsenses. And it is a complete violation of safety measures in an electrical installation. Digital grounding device could create serious safety hazard in the parallel circuits. Neutral current can circulate throughout your building and it can create a lot of problem. Please understand that the electrical, the safety regulation, the CEA regulation measures relating to safety demands 1 mega ohm insulation resistance between neutral and earth within your building. If you install this kind of a device, that's gone. So the operation of this device, I don't want to explain. So with this, I make the conclusion. Electrical accidents are often from faulty equipment. Of course, from faulty wiring also it happens. From loose contact also it happens. So we have to find out each and every, or we have to treat each and every problem in a different way. Sometimes the solution for loose contact may not work for over voltage. Sometimes over voltage solution may not work for a loose contact. So we have to find out the actual problem and rectify it. Often the failures or the accidents are due to faulty equipment. Often safety measures are impossible due to wrong design of electrical installation. As I said, the wrong design of electrical installation, one of the classic example is here, the separate unclassified or undefined networks are used all over India. Recently, I even saw an installation. There are so many earth pits in the factory, and each of the earth electrode in soil, they have made a barricade. All around the earth pit, there is a metal barricade. So, and they claim that we are making additional safety for earth electrode so that people are not going near to the earth electrode and nobody is touching the electrode. So, these undefined networks, of course, is a danger. While selecting the equipment, we ensure that the equipment safety measures are fulfilled, especially in critical applications like hospitals and industrial system. In residential, of course, it may take some more time for such kind of equipment to come out, but industrial and especially hospital areas, already the equipment are there. But what I wanted to tell you is if you go for a cheaper device, of course, you may not get these things. Equipment are deteriorated, resulting in accident if you don't take care of this device. So this is the conclusion. Now I would like to take you to a different subject. All of you are aware that we were taking classes for almost 1.5 years. More than 20 or 24,000 people have participated in various programs with the Surakshit Bharat Abhiyan, as well as the webinars conducted along with BNG. A lot of participants started asking, why don't we start an association? Because for electrical engineers, there is no association, an all India association to take care of the increasing the knowledge levels or increasing the electrical quality of the electrical installation. As a result, last few months we were thinking of making an association. Finally, we decided to make it, and the association is called as National Federation of Engineers for Electrical Safety. The association is almost to be registered. Probably within 2 days, the registration will happen. So the purpose of the association is to improve the quality of electrical installation, create awareness, skill development, and improve safety measures, support CESC, the electrical, the chartered electrical safety engineer. Various state governments are implementing chartered electrical safety engineer. Our association, if it works well, can support engineers to become chartered electrical safety engineer in a good way, in a knowledgeable way, work on new technologies such as solar and electric vehicles, and then a very important subject, facilitate accreditation system for engineers and provide better employability. Accreditation system in the sense, globally, qualification by government agencies are rolled out. Now the ISO standards are recommending to go for accreditation system. The association can become an accredited agency so that the association members can be accredited by the association for various jobs such as designing, erection, testing, and so on. We can also support in standardization, R&D, and test laboratories. With this mind, we started an association. Of course, not only me, along with me, several several engineers are there. So we request you to become a part of the association. Of course, you will get intimations very soon. With this, I would like to stop the presentation. If you are interested to listen to me, or if you are interested to hear anything about the association, you can write to me by email or by mobile phone. So gk@capeindia.net or 9962522244. With this, I would like to stop the presentation. Over to you, Mr. Dominic.